Hi guys, in today's video we will be learning how to solve a binary search program. I'm doing this program in Leetcode. Problem number 704. The question says given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums, which means we will be given an array which is already sorted in ascending order, and we will be also given a target number. We have to find the index of this target number in the given array. The brute force approach will be running along the whole array and finding the index, means checking each and every element, and then getting the, when we find that value, we will be returning the index number. But if the number is the array is too big, uh, time limit will be exceeded. That is not an optimal approach. So we will be solving it through binary search, and that too in recursive manner. Binary search means the array should be already be sorted like this. See the example what we have given here is minus minus 1 minus 1 0 3 5 9 and 12. As you can see, the array is already sorted and the target number is 9. The total number of elements here are 1 2 3 4 5 6 numbers are there. Binary search means we'll assign two variables, start and end. Start will be pointing to the 0th index element and end will be pointing to the last index element, and we will be having a mid, which will be the middle element of this array. Here in this case, the starting element is minus 1, ending is 12. Starting index would be 0 and ending index would be 5. Since it is a 0 index array, we'll be considering 0 indexed array, and our mid value will be the middle of this element, 5 minus 5 plus 0 by 2, which is 2, right? So our middle element will be 3. First, what the binary search algorithm will do is it will check whether the middle element is equal to target number. If yes, it will return the middle index, or else it will check if the middle element is less than target element. Means the array, the target, if this element, see in this example, the middle element is 3, which is less than the target element. It means the target element will be lying in the right side of this array, right? It won't lie in the left side of this array since it is already sorted. So what we'll do is we will assign the start to the middle element and end will be the same, and our middle element will change now. It means our next what will happen is our start becomes 2 and end will be as it is 5, and the middle value will be 2 plus 5 divided by 2, which is nothing but 7 by 2, 3. So 5 will be our middle element now, and after that it will check whether this middle element is less than or greater than target value. It is again less than the target value, so again our middle element will become the in starting index. So starting index will be 3 and ending will be as it is 5, and the middle element would be 5 plus 3 divided by 2, which is 4. Here in this case, the fourth index element is 9, which is our target element. So it will simply return the index of this element, and our output will be 4. Here the output is 4. In this way, we will be solving it via recursion. Firstly, I am assigning a variable n, which will store the length of this array. And then I will be creating a function here, public static int. It will return an integer value, and I'm keeping the name of this function as binary search, and I will pass the array and target as well as the starting variable and the ending variable here. I'm calling it here itself. I'm calling it here binary search, and I'm passing nums, the target. Firstly, our starting index will be 0, so I'm keeping the starting index as 0, and ending will be n minus 1, not n, it's n minus 1. Now here I will check. We should also have a base condition like this. If my starting index is less than or equal to end, if the starting index is less than or equal to n only, our binary search algorithm will work, or else it won't give an appropriate answer, and it won't give a appropriate answer. See, and I'm creating a mid variable which stores start plus n minus start divided by 2. You can also write start plus n divided by 2, but this would be a good approach to store the mid value. Now we will check if our nums of mid, means the middle element, is equal to our target value. In this case, we will be simply returning the mid. Else, in that case, what we will be doing is, we will again call this binary search function only, and my nums will be the same, target will be the same. Else, here in this else condition, what will be the condition is, if my nums of mid, means the middle element, whatever it is there, if it is less than the target element, means here you can see, in this array the length of the array is 6, and our middle element is 3, and the index of this element is 2. This element is less than our target element, so my starting element would become this. It means the target is present in the right side of this middle element, means our starting index will be the mid, and ending index will be the same. Here starting index is mid plus 1, ending will be same. In the else conditions, our target else condition is the middle element is greater than the target. It means our ending index would become the mid minus 1, and starting would be starting only. Ending here will change to mid minus 1. If the target element is not present in this array, they said to return -1. So what I will do is, here I will return -1. Also, don't forget to write return statement here. We will be calling our function until and unless this condition and this condition is true. Here also we will be returning. It means we are calling the function here again and again. Here we are solving the binary search program in recursion manner. It means recursion means what? A function calling itself again and again until a specific condition is satisfied. So we will be calling our binary search algorithm until this condition is true and this condition is true. If this fails, it will simply return -1. If this condition is satisfied and this condition is satisfied, it will return the mid value, means the target of index of the target value. I will run this program. See, the test here, both the test cases have worked. I will also submit this program. Yes, it has run successfully. In this way, you can find the binary search, you can solve the binary search algorithm in recursive manner. Hope it is helpful to you. Please like, share, and subscribe to my channel. Thank you.